Given circle ABC with EA, a tangent to the circle at A.
AC is a tangent to circle CDFG at C. CE and AG intersect at D. And, CD and GF produced meet at E. We are required to prove that BCG is parallel to AE. AE is a tangent to circle FED, and AB equals AC. Whenever asked to prove parallel lines in Euclidean geometry, you should immediately be thinking about the fun angles, corresponding, alternate, and co-interior angles. Looking at line segments, BCG and EA, we will most likely prove that alternate angles are equal, as there aren't any visible corresponding angles, and we weren't given any information that could lead to the use of co-interior angles. So, we will either prove that angle A1 equals angle G2, or angle A4 equals angle B. We are specifically looking at angle A1 and angle A4, because they relate directly to tangent EA. At this point, it is important to note that there is more than one way to solve riders. More importantly, under no circumstances may any assumptions be made. Because we are given that angle A1 equals x, this is an indication that we will more than likely need to prove that angle G2 equals x, for BCG to be parallel to AE. EA is a tangent to circle ABC, which means that angle A1 equals angle C2, the reason being tan chord theorem. We should now look to relate angle C2 to another angle, based on other given information. We were also given that AC is a tangent to circle CDFG, which means that angle C2 equals angle G2, again, the tan chord theorem. We can now deduce that angle A1 equals angle G2, since they both equal x. BCG is therefore parallel to AE, because the alternate angles formed by these parallel lines are equal. Next, we are required to prove that AE is a tangent to circle FED. In order to prove this, we will need to prove that angle E1 equals angle F1. Since we have just proven that BCG is parallel to AE, we can state that angle C3 equals angle E1, as the alternate angles are equal. We now need to relate angle C3 to angle F1. F1 is the exterior angle of cyclic quad, CDFG. We know that CDFG is a cyclic quad, because C, D, F and G lie on the circumference of a circle. F1 therefore equals C3, because the exterior angle of a cyclic quad equals the opposite interior angle. We can now state that angle F1 equals angle E1, since both angles equal y. And therefore, AE is a tangent to circle FED, the reason being, the converse of the tan chord theorem. If you are unsure about anything we have just done, or just want to refresh your memory, these concepts are covered in detail in the workbook, and in the online courses, the links of which have been provided in the description box below. Finally, we are required to prove that AB equals AC. To prove this, we will need to prove that angle B equals angle C1. BCG is parallel to AE, so we can state that angle A4 equals angle B, since the alternate angles are equal. A4 equals C1, the reason being the tan chord theorem. We can therefore deduce that angle B equals angle C1, since they both equal angle A4. AB therefore equals AC, because ABC is an isosceles triangle. If you like this video, subscribe below, hit the like button, and leave a comment to let us know what else you'd like to see. Thanks for watching.